Okay, number 11. 11 is a throwback clear to September. It's a limit problem. So you need to remember the limit flashcard. The limit flashcard says, first check to see if x is approaching infinity. It's not where we would compare terms that are adding. Skip that. Second item on the limit flashcard is factor and divide if you can. There's nothing to factor, so I can't do that. The third item on the limit flashcard was check left and right limits. We now have a new third. The new third is L'Hopital's rule. I want you to have a flashcard for L'Hopital's rule, but it's better to learn the rule first and then figure out what you should flashcard. It's French. Anyone speak French? I do not. But I believe the correct pronunciation is something like L'Hopital, so that's what I say. The French probably wins. But, anyway. Okay, cool. Look, his rule is really, really easy to use. Listen, don't write anything, just watch. The rule is really simple. All you have to remember is test first. If the test doesn't work, you can't use the rule. The test is very, very simple. Plug in the limiting value. So you just plug it in. You don't have to think at all, just plug it in. So we have pi fourths minus pi fourths. Say it out loud. What's pi fourth minus pi fourth?
0.
0. Now you do have to remember the unit circle. So let's see. On the circle, 0's right here. Sign means up and down, so 0. So the sign of 0 is 0. Questions? So what I did is I plugged in so I'm testing here. So in the test, I plug in the limiting value. So I'm finding the sine of pi over 4 subtract pi over 4. Which means I have to determine the sine of 0. I remember from the unit circle that that has a value of 0. I'm done with that part of the test. What I want to have happen on the test is I want to get 0 divided by 0 or infinity divided by infinity. Positive and negative don't matter. So far the test is successful because the top is 0 when we plug in the limiting value. You want me to talk through that again? The test is easy to remember because you do the same thing on the bottom. So if I plug in x equal pi over 4 on the bottom, what happens to the bottom? What do we get? 0. 0 over 0 is a successful L'Hopital test. That's what we want to have happen. Okay? If that doesn't work, you've got to go back and do some other method of finding the limit. So the test is successful, so now all you do is you take the derivative of the top and the derivative of the bottom separately. You do not use the quotient rule. So I'm going to find the derivative of the top. It's d over this variable. So in this case, d over dx. The sine of x subtract pi over 4. Really easy derivative, often is. The derivative of the sine is the cosine of the something multiplied by the derivative of the something. Question? Please.
Why are we taking the derivative?
So we're following a new idea, which is brand new to you, called L'Hopital's rule. The first part of the rule is we have to do the test. If the test is successful, the second part of the rule is to take the derivative of the top separate from the derivative of the bottom.
Okay.
So we're just working our way through the rules. 2 points. Now, I'm watching pencils. I want to go faster than you can keep up. So. Please, Mary.
On the written test, do you have to write down your test, or can you just do it in your
The only problems I've ever seen on the written section that involve L'Hopital's rule specifically say show using L'Hopital's rule. So I would want to show the test. Like I would show this so they can see that I'm checking it. I would show that I'm finding the derivative. Yeah, 2 points. Much more common for a L'Hopital rule question to show up on the multiple choice, where they don't care what you show, of course, you just have to have the right answer. Not a huge concept on the test, I'd say maybe 1 or 2 questions. So between, I'd say, 1 to 3 points total on the entire test, as opposed to the fundamental theorem questions, like 30 points. So here we go. This derivative is easy, because the derivative of pi over 4 would be 0. Dx dx is 1. So the derivative of the numerator is just cosine x subtract pi over 4. Question? So now we need the derivative of the denominator. I have d over dx of x subtract pi over 4. We just discussed that. That's just 1. You want me to talk through that again? Okay, so Justin asked a really good question. He's like, okay, so what are we doing here? We're following L'Hopital's rule. We first test. If the test is successful, successful means you get 0 over 0 or infinity over infinity. And positive and negative don't matter. Next thing, take the derivative of the top, take the derivative of the bottom. Next step in the rule is to, copy a page here, create a new limit problem. So the new limit problem is going to be the derivative of the top divided by the derivative of the bottom. So you write down the limit as x approaches pi over 4. The derivative of the top was cosine x subtract pi over 4. The derivative of the bottom was 1. What L'Hopital discovered was if the test is successful, the value of this easier limit problem is exactly the same as the value of this more complex limit problem. So it's, again, we're using the equal sign. He's telling us that you don't have to find this limit because it's really hard. Find this limit instead. The result will be the same. You need me to talk through that again. Cool. So now we just check left and right limits. We plug in a number that's close to pi over 4. What is close to pi over 4? Subtract pi over 4. Close to 0. Wait, can you need me to do that again? Okay. So now we have the cosine of a number that is close to 0. So I remember my circle. Here's 0. Cosine means the distance from the center to the right or left. So this value is just 1 divided by 1. The answer is 1. That's the value of the limit. So if you use your calculator, you plug in this formula, and you type in an x if you type in pi over 4, the calculator will say undefined. Like it can't find it because 0 divided by 0. If you plug in a number that's really close to pi over 4, you'll get 1. Or like really, really close to 1. So, question? Awesome. Let's do another one.